Hey everybody, my name is Griffin Solakale. I am a developer advocate at Dolby.io, where I will be talking to you about a browser-based metaverse with babylon.js, where we're going to go over how to get started building 3D spaces, metaverses, alternate realities, in overall just 3D environments, all using JavaScript and JavaScript-based environments and packages, which is a really cool and alternative way to think about kind of trying to build these different environments compared to the more traditional methods. So without any further ado, let's start talking about what we're going to go over. So we're going to start off by talking about what is babylon.js in the first place. Then we're going to go over some examples, do some hello worlds. Yes, there's going to be some live coding in this, where then we're going to continue on to some more specifics, like 3D assets and concepts, animating characters, videos as textures, live streaming with Dolby.io to get actual live content being fed directly into your environment, talking a little bit about spatial audio and perception, and then starting to wrap things up. So let's start talking about what babylon.js is in the first place, where in simple terms, it's a JavaScript-based library for 3D graphics rendering, mostly in WebGL, but the whole idea of it is that you're able to use your HTML5 and JavaScript and CSS and all those libraries, but instead of just building a typical website, you're able to build an actual 3D environment together, where it's all about cross-platform game development as kind of a primary use case. But as you'll see, there's a lot of other use cases, like in education, blockchain, data visualization, and a lot of other ones. Microsoft had a lot of kind of the initial play into this, trying to get a lot of people interested in using it and developing it. So there definitely is a lot of longevity and a lot of actual corporate intent and use case into this as well. So you can see some examples of what actually is inside of BabylonJS, some examples of what people have been able to build. You'll see on the very top left, we have Minecraft over here. Somebody actually was able to make Minecraft using JavaScript only, which makes sense given the Microsoft involvement in all of this. Microsoft had bought Mojang a while ago. We have a bunch of different games, including Temple Run. If you've ever played that mobile game before, has been remade in BabylonJS. We see a shooter over here, some Plinko stuff, Space Invaders isn't made, and even interesting over here is that we have a 3D art gallery on the bottom right over here. So this one isn't a game, but is trying to kind of create unique new ways for people to kind of build their own art immersive experiences, as well as a map right next to it on the left of it over here, where people are trying to kind of take the whole idea of a globe and make that more of an immersive experience on a website as well. So there are a couple of introductory concepts when it comes to actually making something with BabylonJS. It all kind of revolves around one main method, which is called create scene. I'm going to go over this in actual code in a little bit, but the whole idea is that within this method, we can do things like create objects, like the different planes, meshes, but also things like lights and cameras to actually determine the view. So objects aren't just physical things that you might see, but are everything that you'll need to kind of do to be able to interact in this type of world. And these are all done with things like Mesh Builder for eCamera, Hemispheric Light, and a few other ones. The way that you actually define where they are, for the most part, is done in something called Vector3, where you're going to be defining the XYZ coordinates of an object using 0, 0, 0 as the origin, where you can go positive and negative in either direction, so that it's all kind of you're putting things relative together in a scene. One of the benefits of this is that it is all an NEM package that you're able to download, which also includes autocompletions. So if you're using IDE that supports autocompletions for NPM packages like VS Code, you're going to be able to get a lot of help not having to memorize all these and being able to kind of build as if you're in an advanced IDE in the first place. So super, super convenient and pretty easy to use. So let's go see how we can use some of these in the playground. So this is a website called playground.babylonjs.com, which this is the first view you're going to see whenever you do it. You don't have to have anything loaded. This code is automatically created for you. And this is a live instance of BabylonJS that you're being able to run directly in your browser. You can see there's a few different things. You can do JavaScript or the default, but there is TypeScript kind of availability. We're running on WebGL. You can see the version, all of that. If we look at the actual code, we'll see that we're using that create scene function that I just mentioned, where this is where we have all the code. The entire Babylon instance is being kept within this function. And what we're doing here is we're setting the scene. So what we're doing is we're creating a scene, and we can see that we'll be able to do that just by declaring scene, saying that it's a new Babylon scene using the engine, which is declaring that we're using Babylon in the first place. And then we're creating a camera. And the camera is how we're determining the view. This one's using free camera, and you'll see if I scroll over, you can see the vector3 format where you'll be able to see the XYZ coordinates of where we're putting everything in relation to each other. You can also use vector3 0 as kind of a very quick way just to do 0, 0, 0, depending on what you need. Camera control allows us to be able to move the camera directly using the mouse, which can be helpful. There's a couple different ways that you're able to kind of define camera control, but most of the time you don't want it to be static, otherwise why are you doing it in a 3D environment in the first place? And then we're able to do things like creating lights. So if we don't have a light, we're not going to be able to see anything, and lights kind of determine where we're putting in the shadows. Again, you want to define those with the vector3. Let's make sure that I don't change that code. And then we can continue on with things like light intensity, and we can actually see the thing that we're building over here in the sphere. The sphere, we're literally using a mesh builder create sphere, where we're determining the diameter and the number of segments, and then we're also creating the ground plane over here. We can modify some of these things to kind of determine what we're actually seeing. Like I can move the camera from -10 to -12, and we'll click play, and we'll see that we've zoomed back a little bit. I can return that, and I can change the light to go over to 0, 1, 1. And you'll notice the shadow has now shifted on the sphere that we've seen over here. And similarly, we can do similar things, I don't need to save that, with the sphere that we have over here. So diameter is just exactly what it sounds like. It's the diameter of the sphere. I can make the sphere bigger if I want it to be. I can also determine the number of segments, which is very similar to polygons if you're used to old school 3D mesh design, where the number of polygons are going to be how complex the object is. 32 is quite a bit of segments. I can reduce this to 2, and you're going to notice that the sphere is a lot more blocky, a lot lower kind of definition, which is also going to require less processing power if you are trying to render that in real time as well. And then the ground itself, again, width and height, it's pretty self-explanatory. You can make it bigger or smaller. The way you want it to be. And that's just kind of a ground mesh. We're able to change what these actually look like, where we can just decide, hey, I'm going to delete create sphere over here, and I'm going to say I want to create a box. That is actually going to replace the entire one. So we're going to say sphere equals create box, size 1 scene. And if we just put it here, it's going to change that sphere to a box. You'll see that it auto-populates all that code with these different parameters directly put in there. I highly recommend that you start off just playing directly with this BabylonJS playground and seeing what works best for you and kind of what makes sense for you, how you can get comfortable, what you want to build, and just getting started this way. So now that we've gone over those introductory concepts, we can start talking a little bit more about 3D assets and these different concepts, where you can do things like changing colors, where they're all kind of included directly inside an object definition. You can load different files in so that you can kind of import different meshes, and you're able to, again, do things like camera navigation with the mouse and being able to switch scenes. We have some examples pulled up over here. So this one is a mesh loader. So you're not going to want to define everything just by deciding you have a bunch of different squares and you have a bunch of different cylinders and boxes and planes and all of that. A lot of the times you're actually going to have a 3D designer and modeler on your team that's going to be able to make a lot of these figures yourself. See how detailed this is? You can directly import those. So often this is being made in something like Blender or Maya, and you can just directly import it within Babylon. It's going to be able to work, and we can additionally do things like change the different scene that's going on. We have the ability to go through all these different demos that we have over here, and we can see some examples of what the community has been able to build directly there, so that we can kind of decide, hey, like that sounds cool, or get some inspiration what we want to build. I've been kind of showing off a couple of these, so let's check out this one. I haven't showed off this one on any of my talks yet. So as we wait for it to open, you're going to just kind of see that we're able to determine what is shown on a lot of these different screens over here. You'll notice that on the very top, you're going to see that this is still within the playground, but we have this kind of 6 alphanumeric kind of identifier here that's allowing us to actually identify what is being shown directly on that scene. If I go back over to the playground that we have over here, and I click save right here, you'll notice that we actually have that included directly in our URL here. So if I refresh it, it's actually going to now show the playground, but with that box instead of the sphere that we had before. If this is now properly loaded, it is not, so let's try out a different one. We can try out this soda bottle one, which I believe is working because I've tried it out before. You'll see that we have all the different code kind of assets that we have to define this all still within the create scene function, but you don't need to determine everything all directly from the boxes, where you can even pull it through URLs. So if I move over here, you'll notice that this is coming from somebody's GitHub repository where they're able to pull in these different meshes and kind of scenes to define how we can make this soda bottle actually look just by moving around, as well as this background that we see here, where we see a pretty detailed train station going on in the background. That's not being completely derived via meshes, so that should not be the expectation. We can see a couple more different things that are being determined here, like we can use color 3, which is doing an RGB color to help kind of determine where things are, doing things like drop shadows, intensity, and just continuing to get further and further into the rabbit hole of defining how detailed and how complex you want your experience to actually properly look. Continuing on, we have another example over here that has simplified this a little bit more, where we have just the exact scene that we are working with, but just with a bunch of colors now, where we have a couple of cubes and circles and all that. But with mouse controls, we're able to click and move to be able to kind of drag things and make it more interactive as an actual scene that you can kind of define things with. This is, again, very simple. This is just creating the circles, creating the cubes, adding color to them, and then determining what you want your mouse aspects to do. But what we're allowed to do as well is we're able to go to the debug menu over here, which is just an easy function you can directly put within your BabylonJS function. You can see actually what's going on. So if I open up the materials section, we're able to see what all the different materials are made of, see all the different metadata associated with it, where we can kind of define and see what is actually going on from a BabylonJS perspective about what's going on, which is especially useful if something isn't going the way you want it to. And we can also go over to this wrench icon over here, which will let us do things like screenshot and record video directly within the Babylon instance, as well as take a look at different things like exporting. So you can see the scene export button over here. You're able to export a direct file that you can then import directly in if you don't want to save it with the playground. It is completely kind of modular instance where you're able to save, load, and kind of play with a lot of these different things as you go along with the ride. So now that we've spoken a little bit about 3D assets and concepts, we can continue on a little bit further. We're going into VR and AR experiences. This is the Metaverse overall. There is full support for VR headsets where you can try all these different things on your Google Cardboard devices and being able to see these in a 3D environment. This is using WebXR frameworks to be able to kind of make it happen, which is a new replacement for WebVR that has full compatibility for Oculus, Index, and Vive devices, and you can learn more on the Babylon documentation website. We have an example over here, which has a nice little DeLorean, which you can see we're, again, just pulling directly from the scene loader, and this button over here is going to change the view to a VR view. Of course, we are viewing this on a traditional monitor, so it's going to look weird, but if you have a Google Cardboard device, I highly recommend you can see this URL here. You're able to try it out. So I can click on it, and it's going to go in full screen, and you're going to see that we have the VR headset experience, where you're going to have one display for each eye, and it's meant to kind of help immerse you into this actual experience. Additionally, we also have the ability to do animations. So we were doing mouse clicking to click, drag, and move, but what if you want to kind of do more of a traditional character movement? So for this, we want to use render loops to modify the models. This is going to look something like scene.on before render observable, which is going to kind of keep on looping something until something doesn't happen, stops happening, or something does happen, just as you would in kind of a typical logical code loop that you might be able to use. This can do things like moving a character, adding different emotes, and you can assign it to things like key presses like WASD, but you do need to remember to add in your stop commands as you do so. So once more, we have another example over here. We have this 3D model of the woman over here, which I am using my WASD keys to be able to move her around this different environment that we have here. And I can look around, move her, and for emotes, you might not want to physically move your different objects within BabylonJS. You might still want to make them move. So we can see there's an idle animation going on with her, but I can also press B to do a little emote to make her dance, and so on and so forth. These are all fairly basic examples, but just kind of showing off the full capabilities and how this is a real 3D environment creator that you can use all with JavaScript so that you don't need to use some other platform to get it all done. So now that we've gone across some of those kind of basic ideas on how to get started with a 3D environment, let's start talking a little bit about using videos. You kind of want to think about how oftentimes when we're kind of thinking about metaverses, it's kind of about the immersive experience and putting different things inside of them. You are able to put videos directly on top of these different objects that we're creating in BabylonJS as textures. It's all based on HTML5, so this is very similar to a video tag. But instead of actually kind of having a video by itself, we're using it as a texture for an object. So this would be a babylon.video texture file. You can add in play and pause with very similar functions as you would with HTML, with video.play, and you can assign it to GUI buttons as well. I have another example of this over here where we have this big kind of video environment where we are able to play. Sometimes it takes a bit.
City of the day after tomorrow? Say
We're able to mute, and we're able to pause all as we want. I can go over to VS Code where we can actually see how this has been built itself. So if we look at this main.js file that we have already open over here, we're starting a render loop, as we kind of already mentioned, but we can take a look about what the video is actually being done. So we're defining some variables over here of all these different videos that we're setting to null initially, but we're then able to kind of set them as we want. If we look at the actual code, we need to make sure, first of all, that we have the video properly to scale. You have a 9:16, 16:9 ratio for most modern videos these days, but oftentimes it's going to be far too big or take far too much rendering time for it to make sense for you. To do a full 1920 by 1080. So here we're using a scale function to make sure that we're still getting the proper ratio, but at a size that makes more sense for the environment that we're working on. Then we are using the video plane options to define that height and width and also determine which side of the mesh we want it to go on. By default, it will only go on one side, so we're using double side to make sure it actually is on both sides if we turn around. It's a kind of two-way screen. Then we're able to create the plane that we properly want, set the position, and then take the video file that we have and set it to the texture. So we see create video material and texture, and then we have the video that we want to set, and we're properly putting it directly on there. And this is all directly within that loop that we have so that we're able to view the video as we want it to. You can see there's a couple other things, like we just have the light, and we have the ground, and we have the camera control, as we all had before, but we're just adding in a video texture. This is a couple of extra steps for making it a little bit more kind of robust, but at the very end of the day, it's a pretty simple way for you to be able to add a video texture directly within your 3D environment so that you kind of have that interactive experience. So we're able to take this another step further. So instead of saying, hey, we're only using static video that we've already pre-downloaded, we can actually send live streaming data directly into these meshes. And for this example, I'm going to use Dolby.io live streaming for that content, where we're not limited to these video files. This is all going to be real time, and we can get some free API credentials at dolby.io/signup, where you need to know that video texture can extract streams too, where if we assign the source object to the stream URL instead of that local file that we have within our repository, we're able to have that real-time broadcasting directly within the metaverse, which is great for things like different events, concerts, lectures, anything that actually involves real-time interaction with somebody. So if I go over here, I have my dashboard over here, which I just want to get streaming with this token that I've already made. So I'm going to go over to, I'm not on my broadcast. I'm going to go over to my live broadcast. I'm going to click broadcast over here. And I am just going to click start streaming. And I've already set up my token so that if I go and click stream over here, you'll see that this is me. You're going to see the same thing on the camera, but on the screen with a tiny little bit of a delay, which mostly comes from the browser. The browser always adds a little bit of delay based on the rendering that it has to do. It's never a great rendering experience compared to what the live feed is going to be, but it's a very, very quick and close interaction that you're going to be seeing directly going on over here. The way that we're doing it is if we go back over to VS Code, you're going to be able to see that we have a little helper function over here in common called streaming.js. We're putting in all the different credentials. So I'm going to cycle these, so don't try to steal them. They're not going to work after this video. Going to delete them. But we're inputting all our different credentials so that we're able to authenticate. And then what's happening is if we are switching over to the streaming button, which is just a simple HTML button type of endeavor you would do to kind of make that the action that changes things, we're able to take the video texture and we're able to set it towards a different stream object. So this is defining the video itself, but then we're able to kind of take a look at the viewer code over here. So we're authenticating with the name, account ID, token, all of that. We're generating a token for authentication, and then we're setting the view properly to actually get the stream URL. So we are broadcasting, we're getting the event, we're setting the keys, we're making sure that it's all good and proper so that when we go back over to the main.js, when we have the video texture going on the way that we want it to, it's going to be able to see the stream exactly the way that we want it to. So over here, we have the stream button, and then we have the stream URL that we have been able to set from the helper function. So we have the streaming, and we're just setting the URL to that, and it's going to be able to play the stream live exactly the way that I just showed it to you right before. Continuing on towards things that now start to get a little bit more proof of concept-y than exact code examples that we have. Another thing that you might want to add directly into your metaverse is spatial audio. So by default, you're going to have more of a traditional audio where everyone's going to be able to hear everyone exactly the same audio by default. An easy way to change that is to just do a distance, get Euclidean distance between one object and another object, and determine volume based that way. That's still very basic, where you can add in spatial audio, which is something that allows you to not only change loudness based on distance, but also change direction, as most kind of audio experiences use two different drivers. So you're able to kind of determine where in that driver you're able to properly hear somebody. So instead of it just being, hey, I hear you loud, I hear you quiet, I hear you loud to my left, and I hear you quiet to my right, and kind of making sure that we're able to determine it a lot more realistically compared to how we would hear something in real life versus trying to kind of emulate that within a digital world. We don't have an example of this right now that we have built out and showing off for this conference, but you can take a look at some examples of some of our customers that have actually implemented this into their worlds. Odyssey.stream is one example that you can see a screenshot of in our little browser window tab image over here that implemented this directly into their world, where you are able to join with multiple different people and you're able to hear them all coming from different directions. To wrap things up, this is all very much the tip of the iceberg when it comes to babylon.js, where we do highly recommend checking out some links to kind of get a little bit more information. So the first one is that bit.ly link that was just on the link. It comes to this GitHub repository where it shows a self-guided workshop that we've actually been able to use a lot of the content that we've just shown in a self-guided area so that you can kind of take things at your own pace, learn, get information, and start seeing how you can start using a lot of these different things yourself. Highly recommend doing it. This is all open source. We've built this ourselves, and we encourage that you try it out. Next is the Babylon documentation. Of course, I do always like pointing everyone towards different documentation areas. Babylon has some very good ones. It's going to be able to show off all the different things, as well as the different community pages that we've shown off before, like this one, like all these different community marketplace. People are building really awesome stuff, so don't go at it alone blind. Try to use other people's stuff to your benefit. It's really, really cool and really helpful. And then finally, the Dolby I/O documentation. If you do want to start adding in live streaming or spatial audio, we have documentation for you to start building that yourselves just at docs.dolby.io, where you're able to get started building and using all the different streaming. Again, if you can sign up for free right now, you get $50 of free credit, and you're able to kind of really immerse yourself all directly within these different JavaScript-based APIs. So thank you so much for attending this talk. I hope you learned something new and are interested in trying out babylon.js yourselves. If you have any questions, please feel free to tweet at me at Wing of a Griffin, and I'd be happy to answer all this. And I'm not sure if there's a Q&A that's going to be live after this, but please feel free to send me a message, tweet at me, do whatever you want, and I'm happy to direct you to somewhere. So thank you so much, and I'll catch you all later. Bye.